Hey everybody, this is our first intro video. It's something new for me, so I'm going to try to keep these down to about 5, 6, 7 minutes or whatever. So welcome to the semester again. And what I'm doing is a whole bunch of technology that this old dog is just barely able to stay above. Anyway, our first section is about systems of equations, and they sneak matrices in on us, and I wanted to demonstrate that to you very quickly. So if we look at this file we have here, it says we're interested in solving the system. It's got 3 unknowns, 3 equations, pretty typical stuff for Algebra 2 students. And so what we tell Algebra 2 students to do is maybe snag 2 equations and maybe multiply one of them. As I wrote there, it says add -2 times the first equation to the second equation in order to eliminate the x variable. So that's what's happening right here, is we want the x variable to disappear, and it does. And what you would do next is you'd grab 2 more equations and eliminate x again, so that you then have a 2 by 2. You have 2 equations, 2 unknowns, this time with just y and z, and so on, as I say. Now, what we're going to do is use an augmented matrix. There's a word for you. The augmented matrix is we're going to grab, let's get this back down here again. We are going to grab the coefficients from that system above, as you can see right here, and we're going to grab each coefficient, put it into the matrix. Do you see that? 1, -2, 1, 9, etc. And what we'll do is we're going to perform that operation again. We're going to eliminate x, but this time we're going to go, look at this, it's going to sound familiar. We're going to add -2 times the first row, not equation, first row to the second row, and get a new second row. And the way we write what we call row operations, and that's what this is here, is it's good to write these down. I might even quiz you on what was the row op you used and that kind of stuff. So can you see the notation and see if it makes sense to you? -2 R1 is row 1, plus R2 is row 2. Arrow means you're going to change row 2. Okay, so watch it happen. Essentially what we're doing is we are going to think of yourself as going, I'm going to go -2 times -2 times -2 times -2 times. I mean multiplying with row 1. Okay, so for instance, this guy right here is a -2 and then a +2. We're adding those guys together. Okay, so that's how you're getting the 0 right there. And we've eliminated x, so to speak, right? So that's a good thing. And does this look familiar? You've got this new row 2, which is the same as this equation up here. Okay, so what I'm going to say to you now is you continue using row operations until you get a funny looking matrix that looks something like this. You can't see that, can you? Let me scoot it up a little higher. So it looks like this guy at the end. The funny thing about this matrix is it's got zeros down here. And the reason that's really cool is basically you have the last row can be used to solve for the value of z. Okay, once you have z, you back substitute in, but I get ahead of myself. So what are the row operations that we used here? I'll give you for instance. Let's do this in red. Okay, so from here to here, what changed? Take a look at it. This second row turned into this second row, and it's as if someone divided by 5, and I did. So the row op is 1/5, I write it that way, times row 2, new row 2. Okay, think of yourself as dividing everybody by 5, okay? And so think of it as, oh, divide by 5, divide by 5, divide by 5, and divide by 5, and you're there. Okay, so I can sketch out the rest of these row operations for you. What happened next? Well, I rewrote it here. That's all I did is I brought them down. What's next? Hey, man, there's a 0 here where there's a -1 there. Okay, all right. So what happened there was it must have been we did something else. So what was the row operation on that one? We must have gone after and said, row 1, add to row 3, new row 3. Okay, so we use this one again to knock out this negative 1 there. So we get this guy. What happened next? Oh, looks like the 3's that we got here turned into 1. So it must have been take 1/3 and multiply row 3 with it, new row 3. And now we are here. Okay. Lastly, we're going to use this one here to get rid of the 1 below it. Okay. Notice how the strategy is I worked on the first column and now I'm working on the second column. So this last one I think would go -1 row 2, add to row 3, new row 3, and we get here. Okay, so what's so great about here? So those are the row operations that we're looking for. What we can do now with this, and I had to write it in, what we can do now with this guy is we can solve it. So we use this method of back substitute, okay, in order to solve it. So like I said, if you take a look at row 3, what you've got is 0. Remember, these columns are the coefficients of x, y, and z, right? And this line is the equal sign. So now I'm going to go back to equations here, okay? So I'm going to take the bottom row, and it says 0x plus 0y plus 2z is equal to 4. Well, lo and behold, we discovered that z is equal to 2. Okay, that's good. Now we go to row 2 and look at that one. 0x plus y minus z. Well, z is 2 we just found. See how this is? It's just algebra. So what we end up here, it looks like y is equal to -3. Good, good, good. And lastly, go back up, back substitute in, go up to row 1, and it says x1 or x minus 2 times y, but y is -3, plus z, but z is 2, is equal to 9. So that's 8, that's 6, that's 8. Guess what? It says x is equal to 1. Okay, so our solution is 1, -3, 2. Okay, so my thing here, that's wonderful. We've solved this thing. We've solved the system using a matrix. We did it in, 7 minutes so far. I'm going to wrap up real quick. So that's what you're going to do a lot of in class, is you're going to do row operations to discover a lot of things about not just systems, but we quickly move our focus on matrices and work with matrices and the nature therein. Okay, this is called a triangular matrix, by the way, is when you get zeros down the diagonal underneath what they call the main diagonal. Okay, it's what they call a triangular matrix. So the strategy is to do that. And what I'm saying is you go one column at a time. So you're thinking, I'll leave the 1 there and I want to get zeros there. And then later on with that guy 1, 0, 0, I'm going to use the 1 in the middle or whatever it ends up being. And I want to get zeros under it. So I go first column, then second column, etc. Now, this is the last thing. You can go far, by the way, when you get it in triangular form like that, they call this, put this in black, they call this row echelon form. What that means is you have a matrix and you messed with it, not that guy, but the one with zeros down the diagonal. So it would be this guy right here, row echelon form, okay? All right, so let me erase that mess. Okay, so if you go farther, you can keep going. For instance, you can use this 1 here to knock out the -2 above it, okay? And you can use, and if you do that, you get this matrix here. So the row op was probably twice row 2, add to row 1, new row 1. And then I used this 1 here to knock out the -1s above. So there's a couple of row ops. It would say, take row 3, add to row 2, new row 2. Take row 3, add to row 1. It's not always this nice, by the way. Sometimes you run into fractions, new row 1. And what you've got is what they call, no, still getting used to this, reduced row echelon form. if you have a TI-83 calculator, this is RREF or something like that as one of the operations. Anyway, look what you can see. 1, -3, 2, it's spelled out for you right there, okay? Because the equations are all just saying X is, Y is, etc. Let me erase that so you can see that better. Okay, and there you have it. And that's all that there is for this video. You're going to want to practice that stuff, get solutions. Sometimes you run into no solutions. Maybe there's an infinite number, but I've let this gone too long so far. So what we'll do now is we will stop recording if I can find that thing. There it is, stop recording. Okay, see ya.